Welcome to the course Certificate of Cloud Security Knowledge, also known as CCSK. The topics are divided into 12 domains. Domain 1, Cloud Computing Concepts and Architectures. In this domain, you will learn to define cloud computing models, recognize reference and architecture models in cloud computing, understand cloud security scope, responsibilities, and models. How do you define cloud? What you see on the screen is how National Institute of Standards and Technology's Special Publication 800-145, an International Organization for Standardization, and the International Electrotechnical Commission's document number 22123, one defines cloud. Let's simplify that definition. The cloud providers make networks, servers, storage, applications, and cloud services available to cloud service customer from a shared resource pool in their data centers over internet or a leased line. These resources can be rapidly provisioned and released with minimal management effort or service provider interaction. Abstraction and orchestration. These are fundamental concepts that work together to enable efficient use, deployment, and management of cloud resources. Abstraction in cloud computing refers to the process of hiding the complexity of underlying infrastructure and providing a simplified, user-friendly interface for accessing and managing resources. Virtualization is a primary driver of abstraction in the cloud. However, abstraction extends beyond virtualization through containerization, APIs, and other tools. Examples of abstraction are AWS EC2 and Azure Virtual Machines, which abstract the underlying hardware, letting users run their operating systems and applications without worrying about physical servers. Network virtualization, software-defined networking, SDN, abstracts physical networking hardware, allowing flexible and programmable networking configurations. Storage virtualization abstracts physical storage into logical storage pools, which are easier to manage and scale. Orchestration refers to the automated coordination and management of cloud services and workflows. It automates repetitive tasks and processes, reducing human intervention. Let's explain orchestration using an example. A cloud service customer wants to spin up an EC2 instance in AWS. They log into the AWS Management Console, select the EC2 service, choose the SKU, specify the configuration required, and hit the OK button. Allocating CPU cycles, memory, storage, and spinning up the EC2 instance is all orchestrated. National Institute of Standards and Technology describes cloud computing based on 5 essential characteristics: 4 cloud deployment models and 3 cloud service models. Let's start with the essential characteristics of cloud. On-demand self-service. Cloud service customer can provision or deprovision cloud services as and when needed without being assisted by the cloud service provider. Broad network access. The cloud services are accessible by cloud service customer from anywhere over a private network or internet using any computing devices. Resource pooling. Cloud services are provisioned by consuming resources from pooled computing resources like storage, processing, memory, and network available in the cloud infrastructure. Rapid elasticity. Cloud services can be scaled vertically or horizontally in response to change in demands. This flexibility allows businesses to provision or deprovision workloads without delays or disruptions. Measured service. Cloud service customers are billed based on the consumption of cloud services rather than paying a flat fee or investing in infrastructure up front. This model allows for pay-per-use billing model. Pay-per-second or pay-per-minute billing is a refined approach of the pay-per-use model. If you consume a cloud service for 2 minutes and 15 seconds, with pay-per-second billing, you would be charged for exactly 135 seconds. With pay-per-minute billing, you would be charged for 3 minutes because any fraction of a minute is typically rounded up. Cloud deployment models. In this segment, we will be covering the different cloud deployment models. Each deployment model is defined based on ownership. Who owns the cloud infrastructure? Accessibility. Who has access to the cloud infrastructure? Responsibility. Who is responsible for managing the cloud infrastructure? Public cloud. This deployment model refers to cloud services that are made available to the general public and organizations by third-party cloud service providers such as Amazon, Microsoft, or Google. The cloud infrastructure is owned, managed, and maintained by the third-party provider. Public cloud is multi-tenant and has an exposure to security risk due to infrastructure being shared between different tenants. Private cloud. This refers to a cloud infrastructure that is exclusively used by a single organization. The cloud infrastructure is fully owned by the organization and hosted within organization's data center or in a third-party provider's data center. The cloud infrastructure is managed by the organization or by a third party. Private cloud is single tenancy, offering greater control over the environment and reduced exposure to security risks due to dedicated infrastructure. Examples of private cloud are Rackspace Private Cloud, IBM Cloud Private, Microsoft Azure Stack, VMware vSphere, OpenStack. Community cloud. This refers to cloud infrastructure that is used by a specific group of organizations with similar requirements. The ownership of cloud infrastructure can vary depending on the agreement among the participating organizations. It can be one of the participating organizations or jointly owned by organizations part of the community. These participating organizations also can leverage a cloud service provider where a dedicated cloud infrastructure is provisioned only for use by the participating organizations. AWS GovCloud, Azure Government, Google Cloud for Government are examples of community cloud owned and managed by a third party. Community cloud is multi-tenant. Hybrid cloud, a cloud computing environment that combines two or more distinct cloud deployment models from the same or different cloud service providers that are connected and interoperable. In hybrid cloud, the cloud service customer is responsible to develop framework or standards to establish interoperability, not the cloud service provider. A leased line, VPN configured by the cloud service customer or internet can be used to establish communication between the cloud deployment models. The customers can use the framework or standards used to establish interoperability for data exchange, application communication, cloud bursting, backup and disaster recovery between cloud deployment models in the same cloud service provider or a different cloud service provider. The most common example of hybrid cloud is an organization using a combination of private and public cloud, where the public cloud is leveraged for burst traffic during peak demand or used for backup and recovery. In this section, we will discuss the strategy or approach using cloud deployment models and multiple cloud service providers. They are multi-cloud, intercloud, cloud service federation, and federated cloud. Keep in mind, these are not cloud deployment models. Multi-cloud. This is not a deployment model, but a strategy or approach. It refers to the use of two or more distinct cloud service providers, regardless of the cloud deployment model, to meet business requirements. In a multi-cloud approach, the cloud environments work independently from each other, with or without interoperability. When using a multi-cloud strategy, the focus is on vendor independence, distributing workloads on distinct cloud service providers for redundancy and best features. One can get easily confused between a hybrid deployment model and a multi-cloud approach. Usage of distinct deployment models and interoperability between them defines a hybrid cloud, whereas usage of distinct cloud service providers with or without interoperability defines a multi-cloud. On the screen you have a public cloud from Azure and a public cloud from AWS. This is an example of multi-cloud. Next you have a private cloud from Rackspace, a public cloud from Azure, and a community cloud from AWS. There is a leased line connectivity between Rackspace and AWS for data replication. This cloud setup is another example of multi-cloud environment. Next you have a public cloud from Azure and a community cloud from AWS connected over a VPN for interoperability. This classifies as a multi-cloud. This also classifies as a hybrid cloud because there are two distinct cloud deployment models and there is interoperability. Intercloud. This refers to an interconnected global network of clouds. It represents a collaboration between multiple cloud service providers that interconnect their services to create a unified network of cloud environment. The cloud service providers are responsible for establishing framework or standards for interoperability. The cloud service customer leverages these frameworks or standards to create an interoperable cloud environment, using same or different cloud deployment models from distinct cloud service providers. On the screen, you have a public cloud from Azure and a public cloud from AWS, which are interoperable by using framework or standards established by the cloud service provider. This is an example of intercloud. Next, you have a private cloud from Rackspace, a public cloud from Azure, and a community cloud from AWS. They are interoperable by using framework or standards established by the cloud service provider. This is another example of intercloud. Cloud federation. This is a terminology associated with cloud strategy and approach. It refers to the interoperability and trust relationship established between multiple cloud service providers. The goal of cloud federation is to allow seamless interaction, resource sharing, and identity management across different cloud service providers while maintaining security, compliance, and governance. A cloud environment that is part of this federation is called a federated cloud. The next topic in Domain 1 of CCSK v5 is anything as a service. This is a broad term covering the wide range of IT functions or services delivered as a cloud-based offering, primarily over the Internet. Some of the examples are listed on the screen. These IT functions offered as a service will always fit into one of the three cloud service models. Cloud service models. This refers to the different ways in which cloud computing resources and services are delivered to consumers. These models define the level of abstraction, level of control, management, and responsibility shared between the cloud service provider and the cloud service customer. The three cloud service models are infrastructure as a service, platform as a service, and software as a service. CCSK version 5 also refers the cloud service models as SPI, S from the software in software as a service, P from the platform in platform as a service, and I from the infrastructure in infrastructure as a service. In the infrastructure as a service model, cloud users have the ability to provision virtual infrastructure components, including network, compute, storage, and their chosen operating system. They can then deploy their applications and data. The responsibility for managing the virtual infrastructure, operating system, applications, and data lies with the cloud users. Meanwhile, the cloud service provider is responsible for the physical infrastructure, such as data center, physical servers, leased lines, physical networks, storage devices, and other hardware. Examples of infrastructure as a service are Elastic Compute Cloud, Azure Virtual Machines, Google Compute Engine. Platform as a service. This service model provides a platform allowing cloud users to develop, run, and manage applications without the complexity of building and maintaining the underlying infrastructure. Platform as a service often includes integrated development tools, middleware, databases, business analytics, and other services that make application development easier and faster. The cloud service provider is responsible for securing the infrastructure, such as hardware, network, and operating system, including the platform and middleware components. The cloud user is responsible for securing their application code, data, and configurations within the platform. Examples of platform as a service are Microsoft Azure App Service, AWS Elastic Beanstalk, Google App Engine. Software as a service. In this service model, an application that provides a certain business functionality is made available to cloud users by the cloud service provider or by an application vendor that is leveraging cloud. Cloud users can access it from a web browser, mobile app, or lightweight client application. Cloud users are responsible for user onboarding, offboarding, data, and other governance aspects related to the application. The cloud service provider or application vendor is responsible for application and its availability, software updates, feature upgrades, bug fixes, servers, storage devices, networks, and infrastructure. Some of the examples of software as a service are Netflix, Salesforce, Zoom, and Dropbox. Shared security responsibility model. This defines the security responsibilities of cloud service provider and the cloud service customer. The shared security responsibility in cloud is discussed in the context of cloud service models. Because every service that is offered by a cloud service provider belongs to one of the 3 cloud service models. The security responsibilities of cloud service provider and the cloud service customer differs with each cloud service model. On the screen, you have the shared security responsibility model. This outlines how security responsibilities are distributed between the cloud service provider and the cloud service customer in the different cloud service models. In some layers, the responsibility is shared between CSP and CSC. And in some layers, the CSC is exclusively responsible. And there are layers where the cloud service provider is exclusively responsible. Let's look into who is responsible for what at the different layers in the cloud service model in detail. Physical security layer. This layer defines the responsibility of physical security of data center, buildings, and other supporting infrastructure. Some of the aspects of physical security are perimeter security, defending the external boundaries of the data center by implementing fencing, gates, barriers, and restricted vehicle access. Access control, another aspect of physical security, restricting access to data center and other facilities by using biometric authentication, smart cards, and other access control measures. Surveillance, monitoring activities in and around data center and premises by using CCTV, security guards, or patrols. Environmental controls. This is another aspect of physical security. This ensures safety of physical environment by implementing fire detection, suppression systems, temperature and humidity controls to prevent equipment failure, earthquake and flood resistance in building designs. Asset protection. This is another aspect of physical security. This prevents theft, tampering, or damage to IT hardware. Inventory management, tamper-evident seals, and hardware disposal protocols to protect sensitive data helps in asset protection. Redundancy and disaster preparedness. This aspect of physical security ensures data center resilience by redundant power supplies, cooling systems, network connections, backup sites, and disaster recovery plans. The cloud service provider is exclusively responsible for managing, securing, and maintaining the physical security layer in all the cloud service delivery models. Storage layer. This layer has the storage devices such as hard disk, solid-state drives, non-volatile, memory express drives, storage area networks, network-attached storage, tape storage, and optical storage. Asset protection, access control, redundancy, and availability of storage device and systems are the security responsibility in this layer. The CSP is exclusively responsible from layer physical security to storage in all the cloud service models. Servers. A physical server is a hardware system designed to provide computing resources such as processing power, memory, storage, and networking capabilities. Asset protection, access control, redundancy, and availability of servers are the security responsibility in this layer. The CSP is exclusively responsible from layer physical security to server in all the cloud service models. Virtualization layer. This layer lets customer create a virtual, rather than physical version of an IT resource, such as servers, storage, networks. It allows multiple virtual environments to run on a single physical hardware system by abstracting and allocating hardware resources. Let's discuss some of the security challenges in the virtualization layer. Hypervisor vulnerabilities. Exploiting unpatched or misconfigured hypervisors to gain unauthorized access to customer virtual machine. Denial of service attack. Resource overloading or attacks on the hypervisor will impact availability of the virtual machines and cloud services leveraged by cloud service customers. VM escape. This occurs when an attacker breaks out of the isolated environment of a virtual machine and gains access to the underlying hypervisor. From there, the attacker can potentially control other virtual machines running on the same hypervisor or compromise the hypervisor itself. VM hop. This occurs when an attacker moves laterally between virtual machines on the same hypervisor, without necessarily affecting the hypervisor. Data leakage. This is another hypervisor vulnerability. The inadequate isolation between virtual machines used by separate cloud service customers may lead to unintended data exposure. The CSP is exclusively responsible from layer physical security to virtualization in all the cloud service models. Next comes the OS layer. This layer is responsible for the operating system that gets installed on the virtual machine running on the hypervisor. Some of the security considerations when it comes to the operating system are: regularly apply OS updates and patches, use strong authentication and limit the use of administrative accounts for essential tasks, restrict access and permissions by using the principle of least privilege. Use the built-in firewall to control inbound and outbound traffic. Use antivirus and anti-malware software to detect and remove threats. Perform regular scans to identify potential vulnerabilities. Secure network services by disabling unnecessary network services and protocols. Encrypt data to protect data at rest. Implement logging and monitoring. Hardening the OS by removing or disabling unnecessary applications, services, and features. Maintain backup and disaster recovery. In the infrastructure as a service model, the customer is responsible for securing the OS layer. In the platform as a service and the software as a service model, the CSP is responsible for securing the OS. Middleware layer. This is a software that acts as a bridge between different applications, systems, or components. Depending on the application requirements, the middleware component will be leveraged. On the screen, you have some examples of middleware components. Some of the security considerations when it comes to middleware are: enforce strong authentication. Middleware often handles sensitive data, making it a target for unauthorized access. Encrypt data. Middleware process, store, or transmits data. Sensitive data must be encrypted at rest and in transit. Misconfigurations. Default settings or improperly configured middleware components can be exploited by attackers. Supply chain risk. Middleware software from third-party vendors can introduce risk to the application and data. In the infrastructure as a service model, the customer is responsible for securing the middleware layer. In the platform as a service and the software as a service model, the CSP is responsible for securing the middleware layer. Runtime. Runtime components are all the resources, libraries, frameworks, and execution environments necessary to run the application after it has been compiled. Some of the security considerations when it comes to the runtime layer are: insecure dependencies. Third-party libraries or frameworks included in the application runtime may have unpatched vulnerabilities, Runtime configuration issues. Misconfigured runtime environments can create attack vectors. Runtime attacks on containerized environments. Containerized application runtime components might be vulnerable to container breakout attacks. In the infrastructure as a service model, the customer is responsible for securing the runtime layer. In the platform as a service and the software as a service model, the CSP is responsible for securing the runtime layer. The next layer in the shared security model is application. The application gets installed on the operating system, along with any runtime and middleware components on the virtual machine. Some of the security considerations when it comes to the application layer are security misconfigurations. Improperly configured servers, applications, or frameworks can create exploitable vulnerabilities. Insecure dependencies. Application dependencies, libraries, or frameworks with known vulnerabilities can be exploited. Insufficient input validation. Applications failing to validate or sanitize user inputs properly will make the application vulnerable to attacks. Unprotected. APIs without proper authentication, encryption, or rate limiting makes the application vulnerable. Denial of service attacks. Flooding requests to application, rendering it unavailable to legitimate users. Business logic flaws. Design or implementation flaws in application workflows that attackers exploit to bypass intended functionality. In the infrastructure as a service model, the customer is responsible for securing the application code. Any middleware and runtime components installed on the operating system. The customer is responsible for the application layer in the infrastructure as a service model. In the platform as a service model, the customer is responsible for securing the application code. The CSP is responsible for securing the underlying platform, which includes virtual machine, operating system, middleware, runtime, and other platform services. The CSP also offers tools to enhance application security. In the software as a service model, the CSP is responsible for securing the application code and the underlying platform, making the CSP responsible for securing the application layer. The next layer in the shared security model is networking. In the infrastructure as a service model, the CSP secures the physical networking devices such as leased lines, routers, switches, and cables in the CSP's data center, secure virtualized network infrastructure such as virtual private cloud or VNets for the customer, ensure there is network segmentation and isolation between customers, offers managed DNS services, load balancing, and traffic distribution tools, provide tools for monitoring network traffic and generating logs. The customer is responsible for configuring the virtual network resources, such as subnets, routing tables, and peering. Configure DNS records, load balancing policies, and SSL termination settings. Configure and analyze network logs and set up alerts for unusual activity. Ensuring only authorized people has access to the virtual network. Restrict inbound and outbound access to network using network access controls. Encrypt network communication by using transport layer security. In the platform as a service model, the CSP is responsible for securing all of this. The customer is responsible for configuring and securing application-level networking, such as secure API communications, secure communications by encrypting data in transit, traffic management and routing, usage of load balancers to control how requests are distributed between application, leverage web application firewall to help filter and monitor HTTPS traffic to protect against attacks like SQL injection or cross-site scripting. In the software as a service model, all the responsibility mentioned in the infrastructure as a service model and the platform as a service model becomes the CSP's responsibility. The next layer in the shared security model is data. In all the cloud service models, the customer is legally responsible for the data. In other words, the customer, being the data owner, is responsible for protecting the data, not the cloud provider by law. In the infrastructure as a service model, the CSP is responsible for the physical security of storage devices, offers services to encrypt data at rest, in transit, and in use, provide IAM and storage access policies, offer backup services or tools for creating snapshots and disaster recovery, offers tools for logging and monitoring data access and usage, ensure cloud infrastructure complies with industry standards such as SOC 2 and ISO 27001. The customer is responsible for data classification and lifecycle management, encrypt sensitive data, configure IAM roles and policies to control who can access data, configure data retention, backup, and recovery, monitor data usage, suspicious activity, or unauthorized access, provision, configure, and secure storage services, configure TLS for secure data transfer between cloud services, ensure compliance such as GDPR, HIPAA to meet business requirements. In the platform as a service model, the CSP and the customer shares the security responsibility. The CSP is responsible for the physical security of storage devices and underlying physical infrastructure where the data will be stored and processed. The CSP provides, manages, and secures the database, storage services, and is responsible for availability, scalability, patching, and updates to the database and storage services. The customer is responsible for securing their data stored on the database and storage services, configuring scaling parameters, and when to patch or update the database. Most of the platform as a service offerings of database and storage services provide automated backup. The customer is responsible for configuring, retention, and other backup policies. The CSP provides disaster recovery based on the options selected by the customer, availability zones, or at the regional level. The customer has to choose the disaster recovery based on business requirements. The CSP provides default platform-level encryption for database and storage services. It is up to the customer to use application-level encryption, customer-managed, and bring-your-own keys. The CSP provides cloud services that are certified for industry regulations such as GDPR, HIPAA, but it's the customer's responsibility to ensure data compliance with industry regulations. The CSP provides IAM tools. It's the customer's responsibility to implement proper IAM policies, settings, and access controls. In the software as a service model, the CSP, or the software provider, is responsible for securing the underlying infrastructure, platform components, and application code. Provide encryption by default. The CSP ensures high availability of data and disaster recovery, and provides limited backup. The customer is responsible for the data. The customer must configure backup retention policies and perform additional backups if needed, managing access to data, protecting data through configurations, policies, and any compliance settings. Configure security settings for the application. Make use of customer-managed keys if the software provider permits. Implement data loss prevention to protect data. The next layer in the shared security responsibility model is identity and access management. The responsibility of identity and access management is shared between the customer and the CSP in all the cloud service models. The CSP provides functionalities like users, roles, access control policies, multi-factor authentication, API access and authentication, logging and monitoring. The customers can use the identity and access management functionality offered by the CSP to secure the cloud services, application, and data, or leverage a third-party vendor that provides identity and access management functionality. The next layer in the shared security responsibility model is configuration. The number one reason for security breach in cloud is misconfiguration of cloud services. An AWS S3 bucket containing sensitive data that is exposed to the internet, or a database service that allows anonymous logins, are some of the examples. The customer is exclusively responsible for securing the configuration layer in all the cloud service model. With this, we wrap up the shared security responsibility model. Thank you. Join us for Domain 2 of the CCSK course.